Okay, so we're going to look at drawing some Voronoi diagrams and interpreting them. So we'll start with 2A. I've already plotted the point. So let's find some perpendicular bisectors. So I'm going to start by finding the perpendicular bisector of A and B. This is one that I can just draw in. Excuse the shaky hands there. And I'm just going to remind myself that I've drawn the perpendicular of the bisector AB there. There are some other ones that are quite straightforward. So C and B, again, we can just do by eye. You can see that that would bisect exactly there. And then the last one is a little bit trickier. So CA, you can do it by eye. And in this case we will do, because we're going to do a more complicated one, or we'll do a more complicated one later on. So that would be the perpendicular bisector of A and C. Though I will remind you how to use the gradient and also the midpoint later on. But let's just start with this by doing it by eye. Right, now you got to, this is why you need to use a pencil for this, or you need an erasable pen, because there are aspects that you need to erase. But let's start with AB. Kind of wish I hadn't gone through that now. And you array on AB, I mean AC. So we're going to start with AC, the perpendicular bisector I've drawn there, and you're going to erase everything that is on the side of B. I'll put that back in, shall I? So it looks a bit nicer. So B was there. So in that perpendicular bisector, I've removed everything from site or cell, site B, and also cell B, so that sort of zone there. Then when I go to CB, so I'm looking along that bisector now, and I remove everything that's on the side of A. So note what's going on here. So if it's bisector CB, I remove everything that's here that's on the side of A. So let's get the rubber out, and oh good lord, along that, right, on the side of A, it's all of that. Okay, and then the last one is bisector AB. So I rub out everything. What's the letter that's missing? The letter that's missing is C. So I rub out everything on the side of C. So I find it quite kind of useful to have that reminder there. I've just realised this is now a gigantic Voronoi diagram with all this sort of space here that we don't really need. Could have gone for a different sort of coordinate axes there, but you know, I'm not going to change now. Right, so there we go. Lovely. The next question is B. So determine the closest bookstore to Carrie, whose house is located at 1-4. So you're looking at the cells. I had to think about the word. So it's clearly in the cell that has bookstore A. So clearly in this cell here. So it's going to be A. Then part C, you get a fourth bookstore was built. So this is where we'll go through more the method about how you use the midpoint and you use the gradient to draw a perpendicular bisector quite quickly and effectively. So the fourth bookstore was built recently at 3-5. So I've added that bookstore, which I think was called D. Well, yeah, that makes a lot of sense, doesn't it? So there is D. Now, we'll start with an easy one. So I'm going to do this with a dotted line. Should we keep? Yeah, let's go purple still. So we're in the cell that contains C. We're in cell C. So you start by doing the perpendicular bisector of D and C. So let's do this with a dot. No, let's do it a straight line. All the other ones are straight. Right, now, you're now entering a different you're entering a different cell. So now D is entering the cell that contains B. So now you've got to find a perpendicular bisector of D and B. So let's do this the, I would say long way, but you know what I mean. Now, remember some of the notation, or sort of notation we're looking at. They can do perpendicular bisector of DB. I suppose I should write BD, but never mind. Right. So there are two things, remember, that we need to find a perpendicular bisector. You need the midpoint. So the midpoint of D and B, let's write down what D and B are. So B's over here, it's 5, 1. And D is 3, 5. So you find the midpoint. So you just add together the x values and divide by 2. So I've got 5 plus 3 divided by 2. And you add together the y values. And you divide by 2. You're finding the middle point, the midpoints. So if I do that, 5 plus 3 divided by 2 is 4. And 1 plus 5 divided by 2 is 3. So the midpoint is 4, 3. So let's pop that on our graph. What colour to use here? Can you use in purple? Let's go grey, why not? Right, okay, so 4, 3 would be here. There's no massive surprise. It's actually on that line. Right, so there is the midpoint. Now we need the gradient. So we know the midpoint lies on that perpendicular bisector, so it gives us a starting point. But we also need the gradient, see which direction we're going in. So for dB, in order to find a gradient, remember it's change in y over change in x. I will remind us of the formula. So you can write it like that, y2 minus y1 over x2 minus x1, which I think is what they do in your formula booklet. So we're subtracting y2 minus y1. Remember, you may want to label the coordinates. So if we call, I'm going to go for this one, for x1, y1, calling up my first set, and then x2, y2, my second set. And then just substitute in, let's keep this purple. So y2 minus y1, 5 minus 1, over x2 minus x1, 3 minus 5. So the gradient then of this line is going to be 4 over minus 2, which is going to be minus 2. We were discussing earlier today, and with some of you individually, we've just found, oh crikey, we haven't found AB, have we? And I can actually scroll on here. So what we've done is we have found the gradient of the line DB. Well, that's not what we want. We want, I'm just going to do this approximately, then I'm going to rub it out. We want, oh my goodness, we want the perpendicular bisector. I'm scrawling it in. So, which is that line. So it's perpendicular. That's why, remember, they share the midpoint. There's the midpoint. Look at it. Right in the middle. That's why we can use it. Right. So we need the gradient which is perpendicular to that. The original gradient then of dB is minus 2. Then remember we need the negative reciprocal. So minus 2 over 1 would flip and become 1 over 2. Remember, negative reciprocal, so minus times a minus, or it would become a positive. So it'd be 1 over 2. And this then helps us draw the gradient we need. So it's going to be positive a half. Remember, again, we were talking about this earlier today. So if it is the top part, the gradient is change in y, and the bottom part is change in x, that gives us a clue then that the top part here is dealing with y movement and the bottom part is dealing with x movement. So for every time I go up 1, because that's y, I'm going to go across 2 for x. So let's try this whatever. So remember it's positive, so I'm going to go, here I go, I would be going in this general direction. So I'm going to go kind of more than we need to. So you go across 2, and up 1. So you're going this way. And that pattern would follow down, which is where we really need it. So it would keep on going this way. So you go down 1, across 2, we're going in the other direction like that. So that is the general gradient that we're going to form. So let's fill that in. So I'm going to do that by just filling in 2 of those key points there. So that means I am going here, I'm just going to try to draw the line between those because that's the direction that we'll be going in, heading into the next the next cell, which is A. So we've hit a barrier. So again, I'm going to have to rub part of this out. So as soon as I've hit a new zone, I am going to erase that part. And now we've moved into a different zone. So we started, different cell, I'm sorry. So remember, we started here. We did the perpendicular bisector of D and C. We've just calculated how to work out the perpendicular bisector of D and B, because it's entered into cell B now. So we've drawn that. It had a gradient of 1/2 and a midpoint of, let's remind ourselves, 4, 3, which enabled us to draw that little line. Now little d is moving into cell A. So now we've got to find the perpendicular bisector of, let's write that down, D and A. So again, I'm going to write it the wrong way around. So if we find the perpendicular bisector of D and A, exactly the same thing as before. You can start with a midpoint and you're going to get the gradient. So let's write down what D and A are. Remind ourselves, so D is 3, 5 and A is 1, 1. So you use the same method we used on the right hand side, so I'm just going to write all that down now. Okay, so I've saved us a little bit of time and I've done the working out. So again, we found the midpoint and we found the gradient of DA or AD. And then, remember, that's not what we need. We need the line perpendicular to that. So we find the negative, or the gradient of the line perpendicular to that. So we find the negative reciprocal, which is -1/2. So we got all the information we need. Right. So our starting point is the midpoint. So we know that lies on the line. So 2, 3, here it is. There's 2, 3. Really clearly labelled there, I think. And the gradient is -1/2. So again, remember, top part, that's the change in y. Bottom part is the change in x. So this time we're moving in a negative direction. So it's a negative gradient. So it's going that way, not like the first graph. That would be a positive gradient, remember? That would be a negative gradient. So we're going the other way. So it is very similar. So let's try and trace this out a bit more quickly. So for every square that we go across, x, 2 squares across, we go 1 up for y. So let's try and trace this out then. So here we go. So I'm going to go all the way from here, I will rub this out later, to there. So I've gone across 2, up 1. Now, I'm also going to have to go down 1/2 and across 1 to get to that point I was at before. So now let's try to draw it in. So we're starting from here and we're going to go to our midpoint. We'll go past the midpoint and then we would go, just a quick reminder, cross 2, up 1 with a negative gradient. And that green line now represents our new area that we found. So I rub out all of this and all of that. So there is our new Voronoi diagram. Let's get, oh, yikes. Let's also get rid of that thing. I can't even remember what that was. And there you go. That's some nicely done now. So I hope that's sort of vaguely clear. Right, so just a quick recap. We will look at D as well, but just a quick recap. When you're adding, I think finding a Voronoi diagram for 3 sites is quite easy. But remember, quick recap. You find when you're adding a 4th site, you find the perpendicular bisector of whatever the 2 points are, whatever cell it starts in. So D started in cell C. So you found that perpendicular bisector. You then were entering site B. So you had to find the perpendicular bisector for D and B. So we worked out the midpoint of that, and also the gradient was -1/2. I beg your pardon, it was +1/2. So there's the gradient there. Then you hit the site A. I keep wanting to say zone. And we found the midpoint, so we drew up to the midpoint from where we entered that zone, which was there, and we had worked out that the gradient was -1/2. So you're going in along in a negative direction there. And then you have completed your Voronoi diagram. So let's finally look at part D. So we're back to Carrie and a house then for part D, and a reminder that their house is located at 1-4, which I put there. That's why the orange dot was there. And yes, indeed, it is now closest to D. So it's in site, it's in cell D, so it's closest to site D. So it has changed now. And there you go. I hope that's sort of vaguely instructive.